Hi everybody, welcome to the first video for the class. This is a review and we will go over all the important material that we need for Calculus 1. Right, before we start, on that side you will see the important material that we need to know, and on the top I will update the list of the questions that we did. There will be no timestamp, so we'll just look over the list and you will see when we do some certain problem. Anyway, let's go right into it. The first one. This is the composition. So g of f of x written as g of f of x. Right. I will start from the outside function. It's going to be 2x minus 4, so we'll have 2. And notice that we haven't put anything inside the parentheses, and that because if we want to, it's going to be f of x instead of x. So we will have 2 times f of x, 4x squared plus 2x plus 8, and then plus the minus 4. Multiply it out, ax squared plus 4x plus 16 minus 4, and we have ax squared plus 4x plus 12. Right, so that's the first one. The key here, of course, g of f of x will replace f of x into this x. Of the outside function. Right. So that is important. But more important is to do this problem in reverse. By that I mean we have a function and we need to decompose that into 2 functions. Right. So let's go to the next one. So to do this, we'll do in reverse. I will put a function, something that have x inside a box. So in that case I will have a box to the 4th power, and with that the box equal to negative 5x plus 18. Now from one function I'll have 2 functions. The first one is something to the 4th power. The second function is inside the box. So we can write g of x equal to negative 5x plus 18, and the function in front of that, let the variable be u or x, pretty much anything. It's going to be u to the 4th and the function of u. Right. And then similarly for 3, we'll put something that have x inside the box, and we have the function 10 over square root of a box, where the box is 7x plus 6. So we have from one function we decompose into 2 functions, where g of x is equal to 7x plus 6, and like that u should have uh, 10 over square root of u. So from one function we decompose into two functions. Oops. Right. So that's 2 and 3. Alright, next we have the slope and the equation of a line, because the material on that side. So first, this we have the slope equal to 2, so that is m, and we have a point, so this will be x1, y1. Equation of the line, y minus y1 equal to m, x minus x1. Just put everything we have. Y minus y1 is 3, slope 2, x minus 6. So we have y minus 3 equal to 2x minus a negative 6, so that plus a positive 6 times 2 is 12, and minus 3 on both sides. We have y equal to 2x plus 15 plus 3 on both sides, 15. So I have that. Next, we have 2 points instead of 1. We don't have the slope, but we still can find it because the formula on that side. The slope of the line that is passing through 2 points. So we have 2 points. Doesn't matter which one which. We just pick one. Let this one be x1, y1, x2, y2, and then we put into the formula. Y2 is 6, y1 3, x1 4, minus 5. So that will be 3 over minus 1, so it's minus 3. So that is the slope. Now we have the slope and the point. We should be able to find the equation of the line. And we use this point. Y minus 3 equal minus 3, x minus x1 is 5. So y minus 3 negative 3x plus 15 and plus 3 on both sides. And we have this equation. Right. Once again, we need to know the equation of the line, which we'll use quite a few times in calculus. So we have that. Right. Next, we go to different quotient. Right. The different quotient, the formula is just that. So let me rewrite that. Right. So in this one we have f of x plus h, and then f of x over h. Right. So let's look at f of x plus h. So for the function f of x, we see there's an x here and a 5x here. So instead of x, we have x plus h. So we put x plus h into this x and into this x. So notice that if we don't have the x, we have that. So instead of x, we have a parentheses, and within the parentheses, we have x plus h. Just put it here. Now I will multiply this out. This is a square, so multiply by itself. That will be 5x, 5h plus 3. Now just multiply this out. Negative will be x squared plus and then 5x, 5h, and then 3. Right. And finally, negative x squared, hx, that will be 2 of them, but with the minus. Minus h squared plus 5x plus 5h plus 3. Right. And then f of x is just the original function. Right. Now we put into this formula. First we have f of x plus h will be this. I put that in a parentheses. Minus x squared minus 2 is x minus h squared, and then pretty much the whole thing. And then minus the function will be in green, I mean blue. Right. Now remove the parentheses. Minus the negative, that turned into a plus, minus, and minus. Right. The important step here is that we see it should be a lot to cancel out. Whatever doesn't have an h, so this one has no h, we should cancel with something. This one has an h, we stay there. This one, we stay there. This one has no h, we'll cancel with something. This one has an h, we stay. This one has no h, we'll cancel with that. So we have negative 2hx minus h squared plus 5h all over h. Now we see that every term has an h, which we can factor out. Just factor out the h, don't factor out the minus. So we have negative 2x, negative h, and plus 5. And all of them have h on the top. We factor out, which will cancel with the h at the bottom. Right. So we'll have just negative 2x minus h plus 5. Note that there will be two important steps. The step that where we cancel everything without an h, and then we cancel the h at the bottom. If the problem done correctly, we should always have those two steps. Right, so that was 6. I'll go to 7. We start with the same thing. Right. So we have f of x plus h original function is 2 over x. We write 2 over parentheses, and inside that we put x plus h. So be just that. And then this is just the original function. Right. Now we put in the formula. So we have 2 over x plus h minus 2 over x and then over h. Right. Now we just need to simplify this. To simplify this, we write the least common multiple of these two fractions. So we have the least common denominator of those two is x and x plus h. We will multiply that to the top and the bottom. I think I should do this. Right. Now just multiply it out. 2 so I multiply to the top. This I should write in blue. Not very important. And then minus 2 over x. And then you have x plus h on top. At the bottom, just have h and x plus h. Once we do that, x plus h cancel out and x cancel out. So we will have 2x minus 2 x plus h over that. Right. What we see here is first we multiply it out. Note that we only multiply the top, we do not multiply the bottom, simply because, like, well, the step above, we always cancel with the h at the bottom, so we want to keep the h by itself like this, because we should cancel that h later. But before that, anything without an h got cancelled out. So this is one of the steps that we should see in most of the problem. I forgot an x here. Right. Now the h at the bottom does cancel out with the h on top, so we end up with negative 2 x plus h. Once again, we see that the step that where we cancel everything without an x and everything without an h got cancelled, and we cancel the h at the bottom. Those two steps should be in every problem. I should say most of the problem. So that was 7. Eight. Right. So different quotient, the formula is still the same. So I have the function at x plus h and the function, the original function. Right, so f of x plus h equal to, we just have square root. Now we're going to put x plus h into x, so pretty much just that. And f of x is just square root of x. So we have square root of x plus h minus square root of x over h. Alright, so now just need to simplify this. A way we simplify this is just like the top, we have to do something to simplify the problem. Now we have to do something as well. This problem, what we do is the conjugates. Let me write that out. So maybe just a difference of 2 square, a minus b, and then a plus b. If we multiply them together, we have a square minus b square. So we're going to do that. So when we have the fraction that is with the common denominator and square root, we use the conjugate. Pretty much the same as this, except it is a plus in the middle. Right. And then we multiply it out. Right. We can use the formula, or we just multiply that manually. The square root times the square root, we have the square root with the square. Square root x plus h times that will be plus. And then the middle then the last two. Once again, we do not multiply the bottom out, we just keep the h by itself, because that will be cancelled with something. Right. Now the middle terms are the same, we cancel square, cancel with square root, square cancel with square root. So we have x plus h, cancel, minus x. The bottom is still the same. So and as always, everything without an h got cancelled out. And cancel out the h. We will have 1 over pretty much that. So when we simplify the h, we still have 1 on the top. So it's still a fraction. Right. So that was 8. The next is the properties of exponents. Actually, those formulas will be very important. I do not have any nice example for that, so we just have some simple example for those properties. Right. Now it should be simple. So first we have the power goes to this, which means the power will go to everything. So x to the negative 2, y to the 5th to the negative 2, a power to another power. Will be that. So 5 to negative 2, so we multiply those, we have negative 10. And we have x to the 5th, and then y. Right. And now to simplify them, notice we divide two things with the same base. So we subtract the exponent, negative 2, negative 5, y, negative 10. And by default, we can always write this to the first. Never mind. Sorry, that was wrong. The square was for the whole thing. So we have to simplify inside first. Yeah, sorry. I thought it was just the top. Right. So we still have the square outside. Now x, by default, this is to the first power. And then when we divide, we subtract. And then y, by default, this is 1. And we dividing, so we subtract the power 5 minus 1. So we have x to the negative 4. And y to the 4th power square. Now the power square go to the top, go to everything. X to negative 4 square, negative 4 times 2, negative 8. and then y to the 4th square, 4 times 2 is 8. So we can put the positive on top, negative exponent move to the bottom. Except this is minus 2. So this will be plus, that will be minus. And we have x to the 8 on top and y to the 8 at the bottom. Sorry. Right. So we have that. Once again, it was negative 2. And for the whole thing. Right, sorry. Anyway. Next. On this one, will be the same thing. We divide the numbers. 42 over 7, that will be 6. And then we subtract the exponent. 3/2 minus 1/3. Right. So 3/2 minus 1/3, and that is 7/6. So yeah, we can just leave it like that. Next. Now we simplify. In order to simplify this, we have to rewrite x, the square root. We use that formula to rewrite. So by default, we can have this to the first power, and the square root we can write a 2. So that to the 1/2 power. So we have that. Now the 3 at the bottom, we still have 3 at the bottom. That makes 1/3. Then x, we have 1/2 minus 3. Because we're dividing, we're subtracting the exponents. So 1/3. And 1/2 minus 3 is negative 5/2. So we can rewrite as 1 over 3. Now this one has the negative exponent. We can write at the bottom, and the exponent turn to positive. And finally, this we write in the radical form. The top number is the power, the bottom is the index of radical, so that'll be 2. I really don't need to write the 2, so it'll be just like that. Right, so that was 11. Right, next we have the property of logarithms. Right, we will probably need this in the later part of the calculus class, and it would be nice to know these properties. So the first one is if we have log of a sum, log of a product, we will turn this into the sum. So a product, log of a product turn into a sum. Except the power here only for the z, so there's nothing here. It'll be just that. Log base b of y plus. Next, we also have the formula where we have the exponent. We can write that outside. Should be just like that. Right. Next, we can do the same thing. I should say similar thing. This is division. So if we have the product, we turn to a sum. This we have a quotient, we turn into a difference. Right. Next, square root of x, similar to the previous problem. Square root of x will rewrite as square of x we write to the 1/2 power. And 25 we can also write 5 square. We can take the power outside. So we have 1/2 log base 5 of x minus 2, just minus 2. Because we have log base 5 of 5, this will be equal to 1. So pretty much we have 1/2 log base 5 of x minus 2. Right. So that was 13. Right. Log base 5 or 25, you can put that in the calculator to get 2 as well, but we also can simplify this. Yeah, the properties of the log, whenever we need it, if we know it, it will be a lot easier to do. Right. So once again, all the formula is on that side. Right. The next part is rational inequality. There's no formula on that side, but just go ahead and do it. So we want a rational function that is greater than or equal to 0. So first, let's write out when it is equal to 0. So we'll have the top equal to 0. We have x squared, x minus 2 equal to 0. So we have x equal to 0, x equal to 2. So we have those two values. And then the bottom equal to 0. Of course, we know that if the bottom equal to 0, it will be undefined, but we find those values as well. So yeah, put an asterisk here. Right. What we do is going to put in the a chart on the side chart. Pretty much a number line. On that number line, we'll have those numbers in increasing order. We have -3, 0, and 2. The scale doesn't matter, but the order. So -3, 0, and then 2. Also negative infinity and infinity. Right. And here we're going to have the function, just a function. Right. Now we note that when x equal to -3, that is at the bottom equal to 0, so this will be undefined. X equal to 0, the function equal to 0, and x equal to 2, the function equal to 0 as well. So the top is 0, it will be equal to 0. The bottom is 0, it is undefined. Alright, so we have this. So we find where the function is equal to 0, where the function is undefined. Now we just need to know positive or negative. In order to do that, we pick a numbers in between each of the interval, kind of in between. So -4, I'll choose -1, 1 will do, and then 3. I'll put those numbers into this function, or we just put in the function x squared x minus 2 over x plus 3, right? And then we can go to second graph. We have the table of at -4, we will have positive 96. At -1, we have negative. At 1 is also negative. At 3 is positive. Right, so that is one way to do that. Another way to do that is using the table. So hit the stat, run the first one, edit. Right, and clear the list. We have -4, -1, 1, and 3. So have those numbers. Next, for list 2, we will highlight the list. What we enter now is the function, but the function, instead of x, we use the list 1. Let me zoom out a little bit. So we'll see we have x1 squared, so it will be L1 squared. So I will type second 1 for L1 square times L1 minus 2, and then divide by L1 minus plus 3. As you see, instead of x, we have L1, and when we hit enter, we have the values positive, negative, negative, and positive. So that's the same thing as before. Right, and finally, what we're looking for is greater than or equal to 0. So let's just write down, we need greater than or equal to 0. When we look at the chart, let me zoom back in. Right, when we look at the chart, we need to have greater than or equal to 0, meaning it won't be positive. We do not choose the point here, that will be undefined, so that will be an empty circle, and then positive. So that is where it's positive. Next, it has the equal sign as well. So we can choose where it is equal to 0 and where it is equal to 0. So pretty much we have negative infinity to negative 3, a 0, just write a union here, an isolated point 0, and then from 2 to infinity. The parentheses if we do not include a point, and the square bracket where we include a point. So that will be like this. Right, so that was 14. Yeah, we'll do a lot of this in calculus. Next is the review in trigonometry. Right. So we have that. Sine, if we look at the formula, sine is y over r. So, and this is in quadrant 3. So quadrant 3 is the point in here. The point in here, we see that x is going to be negative and y is going to be negative. So, and r is always positive. Right. So from that we know y is negative 7. And r is equal to 25. Right. And now we just need to find x. So pretty much this is x, y, and r. The relation is Pythagorean theorem, x squared plus y squared equal to r squared. So put all the numbers in. X we don't know, y negative 7 squared and 25 squared. X squared equal to 25 squared minus 7 squared, 576. Taking the square root, will be plus or minus 24. Right. But since this one in the third quadrant, x is negative 24 because it is in the third quadrant. So I have x, y, and r. Once we know that, the rest is simple. Just put in the definition of the trig functions. So sine is y over r. We already know that. Negative 7 over 25. Cosine x over r, negative 24 over 25. And tangent y over x. Of course, negative and negative simplify will be just 7 over 24. And reciprocal of sine is cosecant. So we just flip this, or we write r over y. Either way, be 25 over negative 7. Just keep the negative on top. And secant is the reciprocal of cosine. So we flip this, and cotangent, reciprocal of tangent. Right, so we have that. Right. Next, we define trigonometric function based on a right triangle. So we have a right triangle here. This is adjacent to the triangle, and this is opposite to the angle, and the longest side is the hypotenuse. Right. However, we do not have the hypotenuse, the size of that. So we will have z squared plus 3 squared equal to the hypotenuse square. And take the square root on both sides, of course plus and minus, but this is going to be a positive sign, so we just keep it positive. Three squared, let's make it 9 instead. So that is 9, 3 squared. Right, after that, it will be simple. Everything will based on the definition. Sine is opposite over hypotenuse. Z over square root of z squared plus 9. Cosine adjacent hypotenuse. And tangent. Out of ink. Sorry. Tangent, opposite over adjacent. Opposite is z, adjacent 3. Right, and then we have cosecant is the reciprocal of that, so we just flip this. So all hypotenuse over the opposite. Cosine reciprocal of that is secant. Or adjacent, hypotenuse over adjacent. And cotangent is reciprocal of tangent. So we flip this as well. Or adjacent over opposite. So that was 16. Right. Before we go to 17, let's just go over the important formulas, trig identities. So we have this little hexagon. So we have tangent and cotangent opposite to each other. So what we have is anything across from one will be reciprocal of each other. So sine is reciprocal of cosecant, cosine is reciprocal of secant, and so on. So we have those reciprocal identities. Next, quotient. To find the quotient, we just need to, for example, tangent is going to be equal to, if we put tangent on the top, we will have sine over cosine, 1 over cotangent, or secant over cosecant. So we can pretty much potentially write the quotient as, for example, tangent is sine over cosine, secant over cosecant, or 1 over cotangent. And because we can rotate the hexagon as we want to, so cosine will be equal to whatever we want function on the top. So cosine equal to cotangent over cosecant, 1 over secant, and sine over tangent as we rotate. Cotangent, cosecant over secant, cosine over sine, or 1 over tangent. So pretty much whatever function, we keep that on the top, and we have the quotient. And then next, the Pythagorean identities. So cosine square plus sine square equal to 1, 1 square plus tangent square equal to secant square, and cotangent square plus 1 equal to cosecant square. So we go in that direction, and we have that. Except for the last one, we have to memorize. We're going to use this a lot. There's of course a lot more identities than just this, but if we know all of this, I mean, that would be 90% of the trigonometry identities that we need to know for calculus 1. So, meaning most of it. Right, now we will simplify this. 17. So we start with the left hand side. So left hand side equal to, we start with tangent. Is sine over cosine. Cosecant, 1 over sine. And minus sine. Right, so that is the left hand side. I just rewrite that. Next, we multiply it out. Sine x cosine x times 1 over sine x. Of course, that will cancel out. And then minus, we have to multiply the sine x on the top. So, and then we multiply. Right, so we have 1 over cosine x minus sine times sine is a sine square. Both of them over cosine, so that is the common denominator. Right. Next, we have 1 minus sine square. The Pythagorean identity, sine square plus cosine square is equal to 1. So 1 minus sine square, pretty much minus sine square on both sides here, equal to cosine square. So the top, we just have cosine square instead of that. And cosine square divided by cosine, we cancel 1 of the cosine, so we just have cosine of x, and that is the right hand side. Yeah, so pretty much that's how we prove it. So all of the basic identities allow us to do that. So that was 17. Next, 18. Right. So we can go from one side to the other, but let's start from the left hand side then. So secant is 1 over cosine. Tangent is sine over cosine. So we have 1 plus sine x equal cosine x. Alright, so this is the left hand side. The right hand side is that. Right. Of course, if we multiply by reciprocal, we can do that as well. So the way we do that is we multiply 1 minus sine x top and bottom. We have that. But let's prove this instead. So this is the left hand side, and this is equal to the right hand side. Suppose so we have this is on the right hand side, and this on the left hand side. We try to verify that, so we're not sure if this is equal or not. Yeah, we can do it like that. Left hand side, right hand side, not sure if they are equal. Right. Now from here we have a fraction, so why don't we just cross multiply, and so we have 1 plus cosine square, sine x, 1 minus sine x, and cosine square. That is where we cross multiply, and we still don't know if it is true or not, so we still verifying. Multiply them out. Minus sine x plus sine x minus sine square. Still don't know if it is right or wrong, true or false, so still put a question mark here. And we have 1 minus sine square x equal to cosine square, and we just did this in the previous problem, and we know this is true, so everything is true, and we verified it. So to verify something, we can go from the left side to the right hand side ideally, or we just match two sides, and then we verify that by manipulate the equation to something that is true, so that also works. And that was 18. Next we have this. For this one we use the power reduction identity. So first we start with sine to the fourth is sine square square cosine square square, and the sine square is 1 minus sine of 2x over 2, and the cosine square is there's a much better way to do this. It'll be sine of cosine. This is minus cosine of 2x over 2 square. And so we square the top, square the bottom. The top square is 1, I skip a few steps, just do the square, so it'll be 2 cosine 2x plus cosine square of 2x over 2 minus 1 plus 2 cosine of 2x plus cosine square of 2x. I'm going to do that in, of course, 2 square, so make it 4. There's a much better way to do this though. So both of them have 4. So to write everything on the top, 1 minus 1, so that cancel out. Cosine square minus cosine square, that cancel out. The thing that not cancel is it's pretty much that, and cancel we have minus cosine of 2x. Right, so that is one way to do that. Right. Yeah, another way to do this is we use difference of 2 square, so sine to the 4th power of x we still start with sine square square and now the difference of 2 square so we have that. So we have sine square x plus, so do minus first, cosine square x, and then plus this equal to 1, so this pretty much equal to sine square minus cosine square. This, if we use a difference of 2 square, it doesn't help us much. What we do instead is just the power reduction, 1 minus cosine of 2x over 2, and then minus 1 plus cosine of 2x over 2. Now I'll bring everything under 2. 1 minus cosine 2x minus 1 minus cosine of 2x. The 1 cancel out. Negative 2 cosine 2x over 2. The 2 cancel out. We have negative cosine of 2x. Yeah. So either way, we have that, but we use the power reduction. Also, we can use the sum or difference identity, but we try to keep all the identities to the minimum. So we can do that, power reduction, and simplify to that. Either way works, but of course this is similar because we get the sine square plus cosine square equal to 1 out of the way. Right, so that was 19. Now we'll go to 20. Right, this we probably will not need this until the very end of calculus. Right, so what we start with is let inside here equal to theta. So theta equal to tangent inverse of x over 2. Now tangent inverse is x over 2. To get back to the function without the inverse, we will take the tangent on both sides. Right, and with some restriction we can simplify them. So we have tangent of theta equal to x over 2. Right, now we'll use a sketch a triangle. Our tangent is opposite over adjacent. So opposite is x, adjacent is 2. The hypotenuse in that case will be square root of x squared plus 2 squared, or 4. Right, so we have opposite, adjacent, hypotenuse by the Pythagorean theorem. Right, and after that the original problem becomes sine of tangent inverse. The tangent inverse we know is going to be equal to theta, so this equal to sine of theta, and sine of theta is opposite over hypotenuse. Opposite is x, and hypotenuse square root of x squared plus 4. Yeah. So first for this we just rewrite inside to be theta, and so for theta we put in the right triangle based on that ratio, and with that we write opposite of hypotenuse, and we have that. Right. So that is the end of it. So of course there will be a lot more that we need to prepare for calculus, but I think those are cover most of it, and some important skill that we need to know. Anyway, and like I said, it's just the beginning. We will see this, I mean, again, until we see all of this again at some point in the calculus class, but I just want to at least be prepared for it. Right, so that will be the end of the video. Thanks for watching.